Hello everyone and welcome back to the channel. Here's a hypothetical situation for you. So you've been printing for a few days, fairly successfully actually, it's quite a nice change. But all of a sudden, halfway through a print, the X-axis motor just stops rotating. It's buzzing a little bit and seems to be doing something, sort of, but it's definitely not rotating like it should be. Upon closer inspection, you find that one of the connectors, well, one of the terminals and wires doesn't seem to be connected properly anymore. So it's not making a proper connection and not able to rotate the motor. The correct solution here would be to turn off the printer and reconnect a new terminal to the end of the wire using a crimp tool. But how do you know what to get? Like, you don't get any spares for these terminals in the box. What are they called? Where do they come from? Where do you even buy them? Like, I don't know, maybe Google them, ask on a Facebook group with pictures and hope somebody knows. Maybe buy 10 different types, hope one of them fits and just go with that. Then you need a crimp tool as well. So if you don't know the name of the terminal that you're trying to crimp, like how are you supposed to crimp a terminal on the end of it? I have been in that sort of situation myself and I know how frustrating it can be. It's just one very tiny little terminal and it should be really cheap and easy to fix, but it's not because you don't have the right information a lot of the time. And that can be really stressful. So today I want to help with that by providing a really thorough guide on all the popular connectors used with 3D printers. First off, we're going to cover some terminology. We'll keep it quick, but it's useful to make sure that we're all on the right page regarding what a terminal, a plug, a receptacle, a wire and a cable is, because otherwise things can get a bit confusing. Then we'll walk through all the different names of the connectors, where they can buy them, who manufactures them and that sort of thing. And then we'll finish off with a bit of a wire size guide, so you know roughly what size wires you might need for your different applications. While I do understand that this is maybe not the most exhilarating and exciting clickbait topic, I do think it is going to be really useful. So if you don't want to watch now, put it in a playlist so make sure you don't lose it later on when you really need it. Just a quick disclaimer, of course I will provide the best information I can. I have used manufacturer data sheets and all that sort of information to make sure I'm providing you the right stuff. But of course, it's your responsibility to make sure you're selecting the right connectors and wires, etc. for your application. So as promised, we're first going to start off with some terminology, just so we're all on the same page with regards to the different wording that we can use. First off, a wire. A wire is a single conductor. A length of that is a wire. Next we have a cable, which is two or more wires permanently held together that are running to the same destination. Next we have the pitch. This is the distance from one pin to the next, measured in millimeters or inches, etc., and is constant for a single connector. So very common ones for 3D printers are 0.1 inches or 2.54 millimeters. Those are of course the same thing, just in different units. Next we have words like JST, Molex, TMP or Amphenol. These are brand names, so they're not a name of a single connector. If somebody tells you it's a JST connector, well done them, they've narrowed it down to about 30,000 products. So you probably need a little bit more information. Next is terminal or contact. Typically I like to use the word terminal, and this is the metallic part which you crimp onto the end of a wire in order to form the electrical connection. The two different types are pin and socket. A pin is the male type connection, while a socket is the female type connection. Next we have the connector or housing. This is the plastic part which you push the wire and terminal into, and this forms the mechanical connection. There are two types of connector or housing. These are the receptacle and the plug. The receptacle holds the female type terminals, whilst the plug holds the male type terminals or pin. Next we have a pin header. This is normally fixed to a component, allowing for a wire to board connection. Next we have tedious. This is the word normally associated with cutting large numbers of cables and crimping terminals onto the ends of them in order to form all the wiring for your 3D printer. That's going to be it for all the terminology. Hopefully we're on the same page with regards to how boring the process is and also all the different types of things that we're going to be talking about. For now, we're going to start talking about a number of different connectors, terminals, pins, receptacles, plugs, etc. So we're going to start off with wire to board connectors. Wire to board connections are pretty much what they say on the tin. They're for connecting a wire to a board. On 3D printers, you'll typically find these on the control board, stepper motors, and some types of end stops and filament sensors. The challenge with wire-to-board connectors is that as the end user, you typically won't be able to specify what they are. For example, they're typically going to be built into the control board or stepper motor which you've purchased. So what you need to do is identify what's being used and buy the right connectors to plug into them. Good manufacturers will be able to help you with this information, as obviously they've designed the board, so they should be able to provide you with the right information to buy the connectors to connect to it. So now we know what they are and where they're used, let's go through some of the popular types which are implemented. First off, we have the JST XH connector. These have a pitch of 2.54mm or 0.1 inches. They use a wire gauge of between 30 and 22. They're current rated for 3 amps of AC or DC, voltage rated for 250 volts AC or DC, and operate in a temperature range of -25 Celsius to 85 Celsius. This is not a locking connector, but does typically have a good friction fit to avoid it coming loose during light vibration. On 3D printers, these are really commonly used on control boards from, for example, Big Tree Tech or Creality. Next, we'll take a look at the JST PH. This looks very similar to the XH that we just looked at, but is very slightly smaller. This has a 2mm pitch and is compatible with wire gauges of 32 to 24. It's current rated for 2 amps, voltage rated for 100 volts, and temperature rated for -25 to 85 Celsius, and requires a good crimp tool to get it right due to its very small size. On 3D printers, these are really only used in one place, and that's stepper motors. It's worth bearing in mind that some stepper motors have a wire coming directly from the body and a connector on the end. This is typically not this type, but the ones that have a connector physically on the stepper motor body itself, this is the JST PH. Next we have Molex KK254. This is also known as the Molex Mini Latch. It has a 2.54mm pitch, compatible with American wire gauges 30 to 22, rated for 4 amps of current, rated for 250 volts at temperatures of -40 to 80 degrees Celsius. A crimp tool is needed in order to use this terminal. As we just mentioned, there are 2 types of stepper motors. One has a wire coming out of it. These connectors are sometimes used at the end of those. And they're also used on all the Duet series of control boards. The official Molex range for this connector doesn't have a male terminal because they're designed for wired to board connections, as obviously this is the section we're in at the moment. But they do actually have some non-official male connectors because these are used in computers for fans. So in order to have cable extensions for fans on PCs, like custom DIY stuff, a generic Molex compatible 254 male connector does exist, normally in 2, 3 and 4 pin varieties if you're interested. Next we have the Molex QF-50. This is a 2.54mm pitch and is a ribbon type connector. Compatible with American wire gauge of 28 to 26, it uses a wire trap connector, so it's a push fit and no crimp tool is needed. Locking receptacles, which you'd quite often have on the PCB, are available for this connector, but not very often used on 3D printers. They're current rated for 1 amp per contact and voltage rated for 250 volts AC or DC. Temperature range of -25 to 85 degrees Celsius. On 3D printers, these are typically used in 2 applications. The first is graphical LCDs, so your interface at the front, and the other instance is where you might have a much wider, many pin connector for adding a daughter board as an expansion to the main control board. That covers it for the most popular wire to board connectors, so now let's take a look at a kind of generic category I'm naming power distribution. Power distribution is not so much an official terminology for these connectors, although it is sometimes used, but these connectors are responsible for moving the bulk of the power around on a 3D printer, for example, from a power supply to the control board and control board to the heated bed or extruder. So that's why I'm naming it that. The first connector we're going to look at is the JST R Series, also known as ring terminals. These are single wire terminals, so no separate housing or connector is used typically. They can come with integrated nylon or PVC coating. These terminals are easy to crimp, but it's still best to use a tool. These are compatible with American wire gauge 26 to 10. Of course, they're available in many sizes with a number of different ratings, so I can't really provide a specific voltage and current rating. These connectors are often used on screw terminals for power supplies, and they're also great for bonding connections, so earth bonding to make sure all the metallic parts of your printer are correctly earthed. The downside of these is that as there's no mechanical housing, the wire does take all the strain in the event of any pulling, so they're best used for static, non-moving connections. Next we have the JST FV Series, also known as fork/spade terminals. These are very similar to the R Series in pretty much every way. The main difference between the two is that an FV series, because it's not a full ring, can be a little bit quicker to assemble and only applicable in some cases because you don't have to remove the screw all the way in order to insert the fork or spade before clamping the screw back down on top of it. Next we have the JST FVDDF Series, also known as quick disconnect terminals. And again, they're very similar in design to the R and FV series that we've just covered. These are often used to connect from an IEC C14 connector, which is like the external plug with the switch on it, from there to the power supply. But for this application, make sure that you're using the fully insulated versions and not the open ones, just to make sure that those terminals are fully covered, as they can be in quite close proximity on that IEC C14 connector. Next we have the JST AF, also known as blade terminals. Again, these are very similar to the R, FV and FVDDF series that we've just taken a look at. These are a straight flat blade which are used on screw block terminals as an alternative to Ferrules, which we'll take a look at in a second. Next we have Molex Mini Fit Jr, or also known as computer power supply connectors. These have a pitch of 4.2 millimeters, compatible with American wire gauge from 28 to 16, currents of up to 9 amps, of course dependent on the wire, connector, application, etc., and up to 600 volt rating. Temperature ranges from -40 to 105 Celsius. These are a fully locking connector, so are great for wire-to-wire connectors where they could otherwise come loose due to a little bit of motion or vibration. Their high maximum current and voltage tolerance makes them very useful for heaters, such as the heated bed or hot end. A tool is required, but these can be quite easy to do, probably due to their large size and therefore a little bit of acceptance with slightly lower cost tools. Fortunately, they're not too expensive given their great capability. Next we have Ferrules, also known as bootlace ferrules. I'm not sure of the original designer and manufacturer of these. They seem to be widely available from basically everyone. It is not clear who came up with the original design. These are compatible with American wire gauges of 24 to 0, single wire terminals, easy to crimp but does need a tool. Once crimped, they form a square cross section, which makes them really good for use in screw block terminals because you get excellent contact on both faces. These are really low cost and they're easy to find kits of like really broad sizes like this. So you can see a huge range of parts, really not very expensive at all. On 3D printers, these are really commonly used where you have a connection, a screw terminal connection to a PCB, typically the control board, for a heated component, such as the hot end heater or the heated bed. That is it for the power supply connectors. Now we'll take a look at some other general purpose things. I've not really invented a great category for these, but this is all the other stuff that you might want to take a look at. These do kind of fit into some of the other categories of wire to wire, wire to board, but I could be used for power as well. They're just really versatile connectors that you can do quite a lot with. The first one we're going to take a look at is the FCI Mini PV, also known as DuPont connectors. These are really typical and seen all over the place. These have a 2.54 millimeter pitch, compatible with American wire gauges of 36 to 22, current rated for 3 amps and rated for 1,000 mating cycles, temperature range of -40 to 105 Celsius. There's no lock on this connector, so while wire-to-wire connections are possible, I wouldn't necessarily recommend it. Instead, maybe take a look at Molex SL, which we'll take a look at here in a minute. These do require a crimp tool and can be quite difficult, but they are available in a really broad range of pre-made lengths as well, if that's the kind of thing you need. These are not actually used that commonly on 3D printers, but they can be used sometimes in the DIY space, because they're very common to use for Arduinos. As I mentioned, these are rated for 1,000 mating cycles, which means it's great for plugging in and taking out and plugging in and taking out again and again and again. So they can be useful for Arduino projects where you can be plugging things in all over the place. So that's why I've mentioned them. You may have some of these already, and they can sometimes be used for DIY 3D printing. Next we have Molex SL. These have a 2.54 millimeter pitch, compatible with American wire gauge of 32 to 22, current rated for 3 amps, voltage rating of 250 volts, temperature rated of -40 to 105 Celsius. One place you can find these is on the Prusa Mark IIs, Mark III and the Mini, and probably the SL1 as well, because typically all of the Prusa control boards use these as connectors in at least some places. I do really like using these connectors. In my head, in terms of use versatility, they're kind of like the FCI mini PVs or DuPont connectors that we just talked about. But the difference here is that they're locking. So that makes them really great for any wire to wire or where you've got motion and vibration and you just really don't want anything coming loose or possibly coming loose due to vibration. So I've used them on the extrudinator where you have a connection from one drag chain onto another drag chain and you need a connection between them. There is some motion there that is moving up and down all the time, so it's useful to have something you know can't come loose. Also on the extrudinator, I've used them to make the hot end kind of modular, so I can take off that whole X carriage assembly because all of the connectors use these Molex type, which are locking, very easy to insert, very easy to remove, and form a great connection. So that sums it up for all of the actual connectors that we're going to be talking about. Those are hopefully all of the most popular things that you'll find on 3D printers, either DIY from Creality or Prusa or anyone else that's popular. And hopefully if you're doing any little bits of repair, you'll be able to identify the right connector that you need. To find the right crimp tool, all you need to do is Google crimp tool for the name of the connector that you're using. And that should help you with finding the right crimp tool for that job. Normally they do a different range, so one crimp tool can normally do a few different types. So having a couple of crimp tools can get you quite a long way. Before we get on to talking about wire size, I do want to give you some tips for selecting these in the case that you're doing a DIY printer as well. So for any given connector, as we've talked about, they're compatible with a range of different wire sizes. And in some cases, because this range is quite large, it requires more than one different terminal. So the terminal might be suitable for a couple of wire gauges at the top end and a couple at the bottom. So make sure you select the right terminal for the size of wire gauge that you're going to be using. Tip number 2 is to use a crimp tool and not pliers. You should always use a crimp tool when crimping terminals. Pliers will not give you the proper connection and therefore they won't get the proper rating that they're supposed to be able to, and then you may overload them and this is bad. While most of the connectors we've talked about do require their own crimp tool, typically a crimp tool can be compatible with a number of different connectors because they do require very similar sorts of crimping. So you don't need to have one crimp tool for every single connector, but make sure for the connectors you do have, you always have a suitable crimp tool. Tip number 3 is to use locking connectors wherever you can. 3D printers do have a fair bit of vibration and it's useful to ensure that they can't come loose by having something that locks. Tip number 4 is to use matching connectors wherever you can. So for example, don't try and match 2.54mm pitch with just any other 2.54mm pitch. If it uses Molex SL, don't use the old DuPont connector just because it fits. Use the right connector for the right job. That's what's been specified. Try and keep it as consistent as you can. Tip number 5 should be fairly obvious, but make sure that your connectors and terminals, etc. are all rated for the currents, voltage and temperatures that you're going to be using them at. When buying terminals, they come in 2 formats, either individuals, so cut from a strip, or the whole strip. While a whole strip is typically more cost effective, it's designed to be used by a machine, and cutting them off of that strip using side cutters can actually damage the terminals and make them a bit more difficult to use. So while the individuals are a bit more expensive because you've had to basically pay for the process of probably cutting them off the strip because they're probably manufactured on the strip, I would recommend going with the individual ones because it means that they're still properly formed when you start using them and not deformed because of the way that you cut them off of the strip. Hopefully that makes sense. They are a bit more expensive, but in my opinion, they're also worth having. Official crimp tools from the original manufacturers of all of these terminals are quite expensive. In fact, in some cases, very expensive. I typically don't buy the genuine original ones. Instead, I buy, I guess, knockoffs or clones. So you don't necessarily get as reliable connections. So when you're planning a build or planning a repair, do buy a little bit more wire than you need, cut the wires a little bit longer than you think you might need, buy a couple of extra terminals because some of them may not crimp as well as they should, just because you might hold it in a very slightly different position. And if this happens, you will need to cut it off and apply a new one, which obviously wastes the terminal and reduces the length of the wire. So just make sure you're prepared for some failures when you're using less expensive tools. Tip number 8, don't use these connectors and terminals at their rated maximum. Use them a bit below. Make sure you're leaving some allowance for any errors in your calculations, losses in the wires and connectors, and also for safety. tip number 9 is that alternatives are available. Whilst in this list I've tried to list the original name of the original manufacturer and the original series name or number, compatible versions are available from other also fairly reputable manufacturers. So don't be worried about using other connectors that are also compatible. Check that their ratings for current and voltage and temperature, etc. are similar or the same, and you should be able to interchange them without too much trouble. You'll typically find that the ones from alternative manufacturers are a little bit cheaper, and that can save you some money when you're buying 30, 40, 50 connectors to make your printer. So that's it for the tips on helping buy them. Now we're going to finish the video with some information on wire sizes to make sure you're not putting like enormous wires where you only need a little one, or little one where you need enormous ones. So, as of course, the application is going to be important. So it's important that you choose the right item for your application. That's not my responsibility. I will provide you here the best information I can to help you select the right thing. Wire size, which we're talking about here, is in terms of the cross-sectional area or diameter of the conductor. This is the amount of material available for conducting electricity through it. Wire size is really important because although smaller wires will have less diameter, less material, and therefore be cheaper, they also have much higher resistance per unit length. So if at any given length, a set length, a small wire will have higher resistance than a large one. Resistance is a problem because resistance causes losses, which is heat and voltage loss, and both of these things are bad. So now you know why it's important. Here's my guide on selecting wire sizes for your 3D printer. For small items on the printer, such as stepper motors, thermistors, probes, end stops, and other non-heat generating components, American wire gauges of 30 to 24 gauge is typical. For a hot end heater, power is typically in the range of 30 to 80 watts, so the wire gauges used typically here are in the range of 26 to 22. For a heated bed, you need to really be careful with wire selection and understand the power and current because 12-volt beds especially can draw a lot of current. Mains powered beds drastically reduce current but have different complexities due to their introduction of the mains AC. For these, 16 to 14 wire gauge is typical, but as I said, beware, larger, thicker wires may be needed if you're running 12-volt beds at higher powers. I should also mention that running a 12-volt bed at high power is really not recommended from my point of view. Look at least 24 volts, if not a mains powered bed. As I mentioned, this is a fairly rough guide to make sure that you get in the ballpark. When selecting wires, make sure you're looking at their voltage current ratings to make sure that they're suitable for the application that you're going to be using them for. You can calculate the power usage as the current multiplied by the voltage, and you can calculate current as voltage divided by resistance. So that's now everything. That is quite a long video, so hopefully you've enjoyed it. Hopefully it's been really useful to you. If not now, hopefully you can keep it as a reference for things in the future. When stuff goes wrong, you'll have a nice reference as a guide to help you through it. If this was useful for you, please leave a like on the video. Don't forget to add it to a playlist if that's going to help you remember where it is in the future. Of course, subscribe for more videos, not necessarily super like this one, but related to 3D printing. Thank you very much for watching, and I'll see you in the next one.